Okay, I'm looking at a series of problems and wondering which one to do first. There's 5 questions. I'm seeing 2 word problems. They're not long word problems, but nonetheless it does require some effort to read through those. So I'm going to look at ones that I believe is probably the easiest one for me to do, which is number 4. So I'm looking at number 4. And when I say number 4, they give me something. They give me that the product of x and y are 6. They give me an equation which has an x and y in it, and that equals 63. But the question is, what's x squared plus y squared? So my suspicion is I'm probably going to obtain it from the information given and quickly. So the first thing I would do is I'd look at the second equation. By the way, you could substitute if you want. I'm not saying you can't, but I'm looking for something simpler to do. All right, like you could solve for x and y, but that looks like it might not be productive. But I'm not saying you couldn't try that. So I'm going to look to factor it. And to factor the second equation, I notice immediately xy comes out from the first 2 terms. And what would you have left off with? X plus y. From the second group, this is the first group, this is the second group, factor my grouping, a 1 would come out, and you're left off with x plus y equals 63. The next thing I do is I'd factor that. I have 2 terms now, and those 2 terms have a factor in common. That factor is x plus y. And what do you get? xy plus 1 equals 63. So I know what xy is, and I'm going to use that now. So you get x plus y, and xy is 6. That's 6 plus 1 equals 63. So I'm going to get 7 x plus y equals 63. Well, this is convenient. They're nice numbers. X plus y is equal to 9. But they didn't want that. Someone said, you wasted your time doing that. Not really. I'm seeing something now. What am I seeing? I'm going to square both sides. So when you square both sides, what do you get? X squared plus 2xy plus y squared equals 81. And I want to remind you, I know what xy is. It's 6. So it's going to be x squared plus 2 times 6 plus y squared equals 81. X squared plus 12 plus y squared is equal to 81. So x squared plus y squared, subtract 12 from both sides, and that's going to give you 69. All right, so let me just see. Again, I want to make sure I'm understanding. That's question number 4, right? And I want to see if they got 69. Yep, seeing it right over here. All right, let me go back, look for another simple one. And I'm going to say I'm done with this. I'm at the blackboard. I'm just going to erase this, say we're done with problem number 4. And again, you may have a different strategy for that problem, but it should lead to the same answer. And if it doesn't, and you have concerns about that, you probably should reach out to me. All right, let me just erase this business here. And I'm going to go for another simple problem that I think is simple anyway. And I'm going to say number 2 doesn't look too bad. All right, it's a numerical problem. And although I'm not good at arithmetic, I want to point out that I'm hoping the numbers work out pretty nice. So I know that t is an integer, right? That's given to me. T is an integer, and a is an integer. A represents a digit, though, so it's really restrictive. So a is going to be a number from the set, and the set number is going to be from, it could be 0, could be 1, could be 2, yada, 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 all up to 9. But that's it. It's the only choice I have. So what I would do is I try to figure it out. I try to figure out a first, because otherwise it just might be too difficult otherwise. So I'm going to say this is 9 times 230 plus t squared is equal to 492. I don't know that digit yet, 04. Now I realize what someone's going to say, well, let's take the square root of both sides. I don't know what a is. All right, now I could play around with that, but what I'm going to do is I'm going to divide both sides by 9. Now again, somebody can say, you still don't know how to do that division, and you're absolutely right. What I do know is I know rules of divisibility. So I'm going to say whatever this number is, it's divisible by 3 and then 3 again. So what I need to do is find a number that's divisible by 3 and 3 again. Well, what do I know about that? I know the sum of the digits. Let's write this down. That's 13, 15, 15, 19. 19 plus a. So I need to find a number that's divisible by 3. So what a would work there? Well, I'm going to say if a were 2, right, what number would you get? You'd get 21. That's certainly divisible by 3, but unfortunately the 7, which is the second thing I have to worry about, that's not divisible by 3. So a can't be 2. All right, can't be 2. Let's try the next number. And what's the next number where that 19 plus a would become divisible by 3? Well, let's see, 21, 24, right? So how do you get 24? What would make that 24? That would be 5, right? So what number would you get? You get 24. Well, 24 divided by 3 is 8, but 8's not divided by 3, so that doesn't work. Wow, let's do the next one. What's the next number going to be? Well, let's see, we did 21, 24, 27. What would make that 27? 8. Let's see if that works. So if I do that, what's the number? 27. Is that divided by 3? Of course it is. And that's going to be 9. And 9's also divided by 3. So I'm going to say a is equal to 8. All right, so it worked out pretty nicely. Let me get my eraser out. And I'm going to say that this number over here is 8. So the a is 8. All right. Now, again, I'm going to, not that, if I were an exam, I wouldn't cross this out, but I do need more whiteboard. So, I kind of went through the divisibility rules. I did some cases that didn't work out nicely, but I did find a case that works nicely. All right, a is 8. I found that. Now, for me to simplify the problem, let me erase this over here and put a 9 instead. I'd like to do the division just because I really need to get a smaller number. All right, so I'll write this down for you. 9 divided into 4, 9, 2, 8, 0, 4. And what do you get? I'm going to say 5. This would be, let's see, what would that give you? 45, right? And then I get 42, and that's going to be 4. That would be 36, and that would give you 6. Drop the 8 down. 9 into 68, 7 times, right? And that's going to give you 63. And then I get a 5, 0. I'll put a 5 here. 45. And I get 54, which is 6. So I know that 230 plus t squared, it's still a big number for me, by the way, 54,756. So now what I know? I know 230 plus t equals plus or minus the square root of 54756. All right? So here comes my problem, by the way. Again, I'm not that good at arithmetic. So, if I was in a competitive exam, I probably would walk away from this right now and come back to it if I had more time. All right? But that's the integer t, by the way. But I got to figure it out. I got to answer the question. So I'm looking at it, and I'm gonna say 234. But I don't know. Maybe I'm wrong. 234. You may wonder why I'm ending at the 4, because the 4 times 4 is 16. Let me write this down. 16. 4 times 3 is 12. 13. 4 times 2 is 8, 9. All right, let me get my eraser. I'm going to erase the carries. And let me keep going. So I get 0. 3 times 4 is 12. 3 times 3 is 9, 10. 3 times 2 is 6, 7. All right, get my eraser out. Erase those carries. Let's see what you get. 0, 0, 8, 6, 4. Let's add that together. 6, 5, 17, 14. Wow, miracle. 230 plus t is equal to plus or minus 234. Let me erase my baby work. I don't need it anymore. Yeah, I made a mistake, by the way. So t is equal to 230 plus or minus 234. Well, out of politeness, I'm going to do the addition. So t could be 230 plus 234, or t could be 230 minus 234. Oh, you know what? I made a mistake here. It's minus 230. Sorry about that. The reason I was doing it, looking at it, there's no way this is going to work. All right, but now maybe it still doesn't work. Let me take a look at it. T could be 4, or t could be, let's take a look at this, minus 464. All right, so I think I found it. I think I found the t's. These are the two t's are integer values, and this over here. If you want, you can check it. If I were on a computer exam, I would not be checking it. And the reason for that, I'm really kind of comfortable that this worked out pretty nicely, but mistakes can happen. So I want to go to the key, and the key is number 2 now. And they said A is 8. We got that, 4 or minus 464. Okay, we did all right with that. All right, let me get my eraser out. I'm kind of done with this. It's almost like I'm at the blackboard. I'd kind of erase. But remember, all the stuff is in blue for you, and I'm hoping that you understand what's in the blue area is what we're doing at the chicken scratch whiteboard here. All right, let me just take a look. Let me erase this business over here. Now I got to make a decision about what problem to do now. And they're all kind of word problems for me, but I'm looking at it and I don't know. I'm gonna try number 1. It looks like a long word problem, but it says, before going to a garage sale, Elise counted the money she was taking along. After an hour, she counted it again and found that she had spent exactly half of it. The number of cents she now had equaled the number of dollars she started with. So you know what? I'm starting to realize that there's something here they're talking about. I'm going to say C equals the number of cents initially. So initially. So maybe, yeah, initially. That doesn't look right, does it? Initially. I think I spelled it wrong. I'll just say started with then. Sometimes I get confused with spelling. I hate to tell you that. Number of cents started with. And D is the number of dollars started with. So what did she start with? She started with 100D. No, not 100D. She started with D. That's the number of dollars, right? Let's write this down. How much money? So it's D dollars. Well, let's write it in cents then, okay? So I'll just make everything. The money she started with is in cents. So every dollar's worth 100 plus C. This is what she started with. How much money in cents she started with. So remember, D is the number of dollars. C is the number of cents. So in cents, what she started with, right? This is what she has. How much money? All right, let's keep reading it. Let me go back here. So before going to garage sale, Elise counted the money she was taking along. After an hour, she counted it again and found that she'd spent exactly half. So if she spent half of it, what does she have? 100D plus C, and she has half left. This is what's left. What's left? Let's keep reading it. The number of cents she now has equals the number of dollars. Wow, that's confusing, right? So 100D plus C over 2. Right, so the number of cents she has now. Let's write this down. The number of cents she now has equaled the number of dollars she started with. So the number of cents she has now right? The number of cents she has now equals, right? This is tough to read, I know that. The number of cents she now has equals the number of dollars she started with. Well, let's write this down. So how many cents do you have? She has this over here. The number of cents she has left, right? Let's write that down. The number of cents she has left equals the number of dollars she started with. Well, she has that many cents then, all right? So let me just erase that little division bar. And these are number of cents now. This is still money. Whoops. Let's take a look. Keep looking. The number of cents she now has equals the number of dollars to start with. And the number of dollars she has now is half the number of cents. Well, let me write this down. Half the number of cents. Okay? Let's see what we get. I'm going to multiply both sides by 2. 100D plus C. For a lot of people, money's always a confusing concept. Let's see, 100D plus C is equal to 100C plus 2D, right? Let's see what we get over here. You would get 99C, right? I'm just taking C from both sides, and 98D. And they got to be equal, by the way. Well, to make them equal, I guess what I could do is make this thing 99 and this thing, and again, I'm looking for integers or integer numbers. This could be 98. Let's try that out. All right, so I'm going to say $99.98. All right, let's go back and read it. And again, if I would recommend rereading it with the number because it's very confusing, by the way. I'm going to say 99.98. And it says, if we're going to graduate, at least count the money. This is what she had initially. After an hour, she counted again and found that she spent exactly half of it. So how much money should you have? I guess $49.99. Right, so this is what she had initial at first. And this is after an hour, 1 hour later. This is what she had, the second thing she looked at her money. The number of cents she now had equaled the number of dollars. Well, that's true. Let's keep reading. The number of cents she now had equaled the number of dollars she started with. The number of dollars she now had was half the number of cents she started with. Yeah, that makes sense too. 98.49. All right, let's go to the key. This is a tough problem. I thought it was tough anyway. I got a little confused with all the words there. But let's see what you had. Let's see what they did. Yep, right over here. And again, the blue area is what my work would look like after I thought through the problem. All right? And thinking through the problem is my chicken scratch. Let me erase this business over here. And kind of checked it with the wording and stuff. I want to point out, like a lot of times in exams that you might say, gee, could I have guessed at that and got the right answer? Yeah, you can. Be aware of this, though. In a competitive exam, though, they're looking at work. And the more clear it is, the easier it is to understand, the better. All right, now, I'm not saying people don't like people that have numerical sense, but they're looking for elegant solutions. And I'm not saying my solutions are the most elegant. Or I'm just saying that be aware of that. Presentation is everything. So we did 1, we did 2, we did 4. Now what I'm going to do is I'm going to do 5. On Monday, a store put out 100 watermelons to be sold. On Monday, a store put out 100 watermelons to be sold. And some were sold. This is what's left on Monday, comma. Let's see, on Monday, a store put out 100 watermelons to be sold, and some were sold. On Tuesday, the number left over was doubled. So they doubled this number that was left over on Monday. Keep reading it. And let me tell you, on Monday, a store put out 100 watermelons to be sold, and some were sold. On Tuesday, the number left over was doubled, and the sales were doubled. That means they sold this. This is what's left over on Tuesday. You know what? I want to simplify it, though. And that's going to be 200 minus 2x minus 2x. So I'm going to say it's really 200 minus 4x. All right, let me outline this for you again. This was left on Monday. This was left on Tuesday. I'm going to keep reading the problem, by the way. And by the way, we may have to read it from the beginning again and again and again to understand it. So now I think we're on Wednesday, right? On Wednesday, the number left over was tripled. Let me write that down for you. The number left over was tripled. So on Wednesday, the number left over was tripled, and the sales were tripled. Right? The sales were tripled of what they were on Monday. On Wednesday, the number left over was tripled, and the sales were tripled what they were on Monday. What were the sales on Monday? Just X, right? So it's going to be minus 3X. Ooh, they say something in. None are left over. Let's see if we can do this. What do you get? 600 minus 12x, right? Minus 3x equals 0. 600 minus 15x equals 0. This is 600 equals 15x. I got to divide both sides by 15, right? Let's see. That goes in 40 times, right? Let's see if that makes sense. 400. Yeah, makes sense. So let's take a look. How many were sold each day? Let's take a look at it. By the way, I want to write this down, be careful about it. So on the first day, 40 were sold. On the second day, how many were sold? 80. These are the numbers sold. And on the third day, how many were sold? Well, 3 times the first day, so it'll be 120. Right, 40, 80, 120. Now, certainly mistakes can happen. I know I said this a lot to you. Make sure you know what we're talking about over here. Looking at an answer key to try to vet yourself, all right? This is what a lot of students don't do. They don't bother wondering if they're right or wrong. You really need to start considering that. And I want to say, oh, I got it right here, 40, 80, 120. All right, 40, 80, 120. All right, so let me erase my work. Again, I got the blackboard. We talked about it. This blackboard never disappears. You can always rewind the tape if you're watching it. So I feel pretty good about that. And I think I did, all the problems except for the circular Ferris wheel problem. And when I read something, I do visualize it, and sometimes I need to get a really crude picture of a Ferris wheel. So I'm going to do number 3 now, and here's the ground, and then the Ferris wheel looks sort of like this over here. So it says a circular Ferris wheel has a radius of 8 meters. I'll put this over here. 8 meters. Right? A circular Ferris wheel has a radius of 8 meters, and it rotates at a rate of 12 degrees per second. I'm going to write that down now. 12 degrees per second. And this was known as an angular velocity, and we use the letter omega for that. All right? It might not be useful, but I'll write it down. It says at t equals 0, a seat at the lowest point. Well, this is a seat at the lowest point, right? There's a seat here. A seat at its lowest point is 2 meters above the ground. So I'm going to say this distance over here is 2 meters above the ground, and this is the ground. Now, what do they say? They say determine how high above the ground this seat is at 40 seconds. Well, I got to figure out where it is at 40 seconds. So what I'm going to do is take this angular velocity and multiply it by 40 seconds. So 40 seconds times 12 degrees per second. Seconds would cancel off. And what do you get there? I guess you get 480 degrees, right? I want to point out, wheels on the bus go round and round, right? So I hope you realize that this seat has, and maybe I'll use a highlighter here. It certainly went around at least once. All right, and how many degrees would be left over if I did that? Well, you want 360, so now he's got to go 120 degrees more. So I'm going to, try to ballpark what 120 degrees looks like to me. Let me just put in an axis over here. And I'm going to do, so you got to go, again, if he goes 360, there's 360, right? That means there's 120 degrees left to go. So if he goes here, that's another 90, right? So now what he's got to do, he's got to go another 30 degrees. So he's up here somewhere. And the reference over here is 30 degrees. The reference angle is 30 degrees. So what I have to do is realize he's up here now. All right? So I'm kind of, thinking about this from a trigonometric perspective. And certainly I know he's 2 meters here, and this is 8 meters here, the radius. What I got to figure is the height of that thing now. And how would I do that? Well, I'm going to say I know something about triangles, right? So I'm going to put a triangle down here, 30 degrees, 2, this would be 1, this would be root 3. Make sure I didn't do any mistakes here. Yeah, I think that's right. But I want that, I don't want this to be 2, I want it to be an 8. So I multiply everything by 4. And what's that height going to be for now? All right. Now, let me do this now. And you're going to get 4 plus 2, which is 6. I'm adding these numbers together. And 6 plus 8, this is the distance of the ground, by the way, is going to be 14 meters. Let's take a look. Mistakes happen. Much work in the problem. A lot of place for misunderstanding, though. No doubt about it. All right, so, right here, 14 meters. And again, it's all typed up for you. All right, all typed up. All right, I realize that sometimes people, they still have remaining questions, or, maybe they just want to make a comment or they have a question, whatever. As long as I'm not overwhelmed, I'll try to answer you. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. And again, as long as I'm not overwhelmed, I will certainly to respond to you. If a lot of people are reaching out to me, though, I just can't do it. I really can't. All right? In hindsight, again, this is an opinion. In hindsight, I think the toughest question for me was number 1. I believe that's the toughest. I think the easiest one for me is number 4. Now, the last one I chose really wasn't bad. I got to be honest with you, though. 2 could have thrown me for a loop. And what I mean by that, I could have not paid attention to the digit A first. It's important you pay attention to digit A. The next thing is pay attention to the divisors, okay? And also the perfect squares in the problem. 5, not so bad. How to keep track of things, but not so bad. Turns out to be a nice problem, all right? So again, remember, if you need to reach out to me and I'm not being overwhelmed, I'll try to reach back to you. I really do appreciate paying attention. And please, I'm going to finish this out, all right? Thank you so much.